All right, today we're looking at a brand new frontier in AI video. We're talking about getting precise, almost director-level control over how things move. So, you've probably seen those AI videos, right? The visuals can be absolutely mind-blowing, but then the movement is just off. It's weird, unpredictable, sometimes just plain wrong. Well, today we're going to dig into why that happens and how a new framework called Wan-Move is trying to solve that exact problem.
And this really gets to the heart of the challenge for generative AI right now. I mean, it's not just about making cool-looking pictures anymore. The real trick is turning a single static image into a living, breathing story that does exactly what you tell it to do. You know, like telling a bird to fly from this exact branch to that exact branch.
And here's the bottom line. For the longest time, just telling an AI, hey, move this thing from point A to point B, has been a huge bottleneck. And that lack of precision has really held back how useful these amazing tools can be for, actual creators.
Okay, so let's crack this open. How did people try to fix this motion problem before? Let's take a peek at the old ways of doing things.
Basically, the early methods fell into two different camps. On one hand, you had what's called sparse control. Think of it like drawing a big box around an object and saying, move everything in this box over there. It's okay for big, general movements, but it totally fails when you need any kind of fine detail. Then, on the other hand, you had dense control. This is the opposite. It's super specific, using pixel-by-pixel guides. And while you get all that fine-grained control, it often gets lost in the weeds. It doesn't see the bigger picture, which can lead to some really weird visual artifacts, like strange textures popping up out of nowhere. On top of all that, a lot of these older methods forced you to add these clunky external modules onto the AI model. The researchers have a great analogy for this. It's like trying to bolt a brand new engine onto a car that's already finished. It's clumsy, it often breaks things, and it can even mess up the very motion instructions you're trying to send in the first place. Not to mention, it makes the whole system a nightmare to train. And this is where Wan-Move comes in with a totally different and frankly, pretty brilliant idea. They asked, what if, instead of bolting on more parts, we could just talk to the AI in its own language?
Okay, to get this, we have to talk about something called latent space. Now don't worry, it sounds complicated, but the idea is pretty simple. Think of it as the AI's internal blueprint for an image. It's not pixels. It's more like a compressed, abstract map of all the important stuff, features, textures, concepts that make up the picture. It's kind of like the AI's imagination.
So, instead of adding all those external controls we talked about, Wan-Move does something much smarter. It works inside this latent space. This is a huge shift. It's not about adding more machinery. It's about giving the AI better, clearer instructions right where it does its thinking.
So how does this actually work? Well, it boils down to this really elegant process that the researchers call latent trajectory guidance. Let's walk through it.
It's actually a super straightforward four-step process. Step 1, the user just defines a path. Seriously, it's as simple as drawing a line on the screen. Step 2, that path you just drew gets translated from our world of pixels into the AI's world, that latent space blueprint. Step 3, the AI looks at the very first frame and copies the essence of the object you want to move, all its core features. And finally, step 4, it just pastes those features all along the path you drew for every single future frame. It's like putting the object on invisible rails and just letting it glide.
And here's the absolute best part. This whole method requires zero extra motion encoders or big changes to the AI model itself. And that's a game changer. It means the system is super efficient, it's easy to scale up, and it completely dodges all those signal degrading problems the old methods had. It just works with what's already there.
Okay, so we know how it works. But what can you actually do with this new level of control? What does this new director's toolkit look like?
Well, it pretty much unlocks a whole new set of creative powers. We're talking about controlling multiple objects at the same time, pulling off precise camera moves like a dolly or a pan, and, get this, you can even take the motion from one video and apply it to a totally different picture. It opens the door to really complex patterns, full 3D object rotations, all kinds of stuff that was just a pipe dream before.
And it can generate these super controlled, really high-quality video clips that are 5 seconds long. Now, 5 seconds might not sound like a ton of time, but believe me, in the world of AI video generation, that's a pretty big deal. It's more than enough time to create a meaningful shot or a little narrative moment.
All right, but here's the million-dollar question. How does this research model actually stack up against the competition? And yeah, that includes the big commercial players out there.
Well, they put it to the test with a human study. And the results are pretty wild.
You can see here that Wan-Move just blows the other research models out of the water on things like motion accuracy and quality. But check this out, this is the really amazing part. When they put it head-to-head with a major commercial tool, Kling 1.5 Pro's Motion Brush, human testers actually preferred Wan-Move's motion quality and visual quality more than half the time. That is huge.
And this is why that's such a big deal. It's closing the gap between open-source university research and those powerful, closed-off commercial products. It's basically democratizing this tech, putting commercial-grade tools into the hands of way more researchers and creators.
But let's take a step back for a second, because this isn't just about making cooler videos. The implications here are actually much, much bigger.
Think about it. When you teach an AI to understand and copy motion perfectly, you're not just teaching it about movement. You're fundamentally teaching it about cause and effect. You're teaching it the basic physics of our world. You know, if you push a ball, it rolls. It doesn't just float away. Getting that intuitive grasp of how the world works is a massive step towards building more advanced, more general artificial intelligence.
And that leaves us with this one last big question to chew on. If an AI can perfectly simulate the motion of our world, does that mean it can truly understand our world? It's a fascinating question that really blurs the lines between simulation, understanding, and what intelligence even is.